Okay, I'm recording this on the off chance that I nail this the first time. I obviously have low expectations, but let's try it. So that we want to find the total kinetic energy. When? At this moment in time. Okay, so that'll be the linear or translational, the regular kind, plus rotational, the circle kind. So it'll be 1/2 mv squared plus 1/2 I omega squared. I'm gonna factor out that half because I don't like it. So we got, no I'm not, because y'all probably didn't. Okay, what'd they give us? We have a mass. Do we have a velocity in meters per second? We do. Do we have an I? That's 1/2 mr squared. Ooh, we don't have an r. It's time to panic. Don't panic. We can get omega in terms of v and r. So if we have a circle and it's rotating, okay, sorry, I had to, there's a relationship between v and omega. V equals r times omega. I was trying to derive it, but I always mess it up. V equals r omega. This is so important. A equals r times alpha, and x equals r times theta. Okay, let me show you how you can remember this. If you have a circle, all right, and it's rolling, it's going, and let's imagine that it like unwraps its circumference as it goes. Its circumference that it's leaving behind is 2 pi r. And if you wonder, ooh, that's where my drawing pad ends, 2 pi r. If you're wondering, well, how much angle did we get through? How many radians of circle? Well, if we're going through one full circle, that's 2 pi radians. Right, so in circle, it doesn't have the r. But in linear, you have to multiply it by the r. That's how I derive it for myself. So velocity, you have to take the circle, you have to take the omega and multiply by the r. I hope that makes sense. Or you can just memorize this and be like, if you have the angular version, multiply by r to get the linear version. Okay, either way, instead of omega, we're going to put v over r. So I'm going to put v squared over r squared. I'm going to make it capital because that one's capital. And then now we can cancel stuff out. That r squared cancels out with that r squared. And we have a v squared. So this ends up being 1/2 mv squared equals plus 1/4, a half times a half, top times top, bottom times bottom. That ends up being 1/4 mv squared. I'm not great at fractions, but I think that's 3/4 mv squared. So 3/4, the mass is 5.95, the velocity is 13.7, and we square it. Let's try it. 837 points, yeah, 837.566, oop, 566. Yes, that's how to do that.